Ladies and gentlemen, this video will review some questions that you might see on the TSI. These questions come from a free readiness exam provided by a test prep company called Mometrics, and I will link their TSI math prep test that's free in the description. But we're going to work through these and see if we can solve them. Remember, on the TSI, you cannot use a calculator, so all of these will be without a calculator solutions. First question. We are given 9 over 81, and we are asked to find an equivalent fraction. Without showing the possible answer choices, let me show you how any of these where you're asked to find an equivalent fraction can be solved. And the way you're going to solve it is by prime factoring. Prime factoring both the numerator and the denominator. Right, so we're going to prime factor the numerator and prime factor the denominator. Well, how do we do that? All right, let's start by prime factoring the numerator. What you want to do is find numbers that are prime, and if we need to remember what prime numbers are, they start with 2 and they proceed up, and the rule is they can only be divided by themselves and 1. So 2 is a prime number. The next number is 3, then 5, then 7. Okay, 8 is not a prime number. 9 is not a prime number. It's divisible by 3. 10 is not a prime number. 11 is a prime number. 12 is not prime, but 13 is, and it just goes on. So what we're looking, you probably won't need prime numbers beyond this. You're looking for some prime number that can be divided into 9. So 9 divided by 3 leaves 3. So 3 times 3 is 9. And it turns out that 3 and 3 are the prime factors of 9. Okay, so we have already prime factored the numerator. Let's prime factor the denominator, 81. 81 put these in boxes. You don't have to do this. 81 can be broken down into 9 and 9. That's what most people think. So write that down, and then you can break 9 down into 3 and 3, and the other 9 down into 3 and 3. And so 81 is 3 times 3 times 3 times 3. And so now what we want to do is rewrite our original fraction as prime over prime numbers. So instead of, we'll have 9 over 81 equals 3 times 3 in the numerator. You got 3 times 3 in the numerator. And then in the denominator, you've got 3 times 3 times 3 times 3. 3 times 3 times 3 times 3. And now it's time to cancel. So if you have the same number in the numerator and the denominator, you can cancel it. So we can cancel 1 3 in the numerator with 1 3 in the denominator, and another 3 in the numerator with another 3 in the denominator. One common problem is that once you cancel all the numbers in either the numerator or the denominator, what's left? And what's left is 1. So now that we've canceled everything out of the numerator, we have 1. So this equals 1 over 3 times 3. Well, what's 3 times 3? It's 9. So 9 over 81 can be reduced to 1 over 9. And for a number like a fraction like 9 over 81, you may have seen that because you may have known that 9 was a factor of 81 and you could just do it in your head. And if that's the hardest problem you get on the TSI test, good for you. But if you ever have to do it, if the numbers aren't obvious and you don't have a calculator, this is how they did it back in late antiquity. Okay, so we will move on. The next problem requires us to find common denominators. So finding common denominators is always a tough one, and converting from proper fractions to improper fractions. So here's the question. 2 3/4 plus 12 6/8. Okay? Well, before we can add these, we have to convert them into improper fractions. See, these are proper fractions. We're going to convert to improper fractions. So here's the procedure. You multiply the denominator times the whole number and then add the numerator. Again, you multiply the denominator times the whole number, then you add the numerator. So we'll do that here. 4 times 2 is 8. 8 plus 3 is 11. So 2 3/4 can be rewritten. Again, 4 times 2 is 8. 8 plus 3 is 11. 2 3/4 can be rewritten as 11 over 4. Plus, now we'll do this one. 8 times 12 is 96. 96 plus 6 is 102. So 8 times 12 is 96. 96 plus 6 is 102. So the improper fraction is 102 over 8. Well, we can't add these yet because they don't have common denominators. It is relatively simple to make this first improper fraction have the same denominator here because the lowest common denominator is going to be 8. So what do I have to do to 4 to make it an 8? I have to multiply it by 2. But the rule in math is that you can never do anything to the denominator that you don't do to the numerator. So instead of just multiplying this denominator by 2, I will multiply the entire fraction by 2 over 2. And the reason this is okay is because 2 divided by 2 is 1. So essentially I'm multiplying 11 over 4 by 1. And I'm not changing anything. I'm just scaling. I'm just changing the dimensions. I'm doubling the numerator and I'm doubling the denominator. So I'm not changing the proportion between the numerator and the denominator. So 11 times 2 is 22. we'll write it like this. This equals 22 over 8 plus 102 over 8. And now because you have the same denominator, you can add the numerators. So now we just have to add 102 plus 22. I'll do this two ways. First, we'll do it in our heads. So you go like this: 102, 112, 122, 123, 124. So I think it's 124. We kind of get a guess in our heads, and then we check. Just 102 plus 22. 2 plus 2 is 4. 0 plus 2 is 2. And 1 plus nothing is 1. So it's 124. So the answer is 124 over 8. And now the thing is, the answer choices that you're given on the TSI will be in proper fractions. So now we've got to turn this improper fraction back into a proper fraction. And if you read this out in English, it tells you what to do. 124 divided by 8. So we'll do that. Long division. 124 divided by 8. Long division time. How many times does 8 go into 12? 8 goes into 12. 8 goes into 12 one time. 1 times 8 is 8. And then we subtract. 12 minus 8 is 4. So then we bring down the 4 up here. Now we have 44. 8 goes into 44 how many times? Well, let's do our multiplication tables. 8 times 1 is 8, times 2 is 16, times 3 is 24, times 4 is 32, times 5 is 40, times 6 is 48. Oh, that's too much. So 8 times 5, it goes in 5 times. So we'll put a 5 here. 5 times 8 is 40. And then you subtract 40 from 44, and you're left with 4. You should see the next step is we have to place a decimal. So we're going to kind of like go into extra innings with this one. So now we have a decimal, and I'm going to put an asterisk right here because there's another way we could stop the problem right here. But we'll go forward with this just so I can show you multiple ways of arriving at the same answer. When you place a decimal, you can bring down another 0 like that. Okay, so 8 goes into 40 5 times. So that's because it's 8 times 5 is 40. You put a 5 here. And you have 5 times 8 is 40. And when you subtract 40 from 40, you get 0. And you know you're done. And so now you have this 15.5. Well, 0.5 is half. It's a half, so it's 15 and a half. 15 and 1/2. And that would be the answer to the question. Now, real quick, I want to kind of rewind. Of course, I can't rewind, so I'm going to just write down what we just did. 124 divided by 8, because I want to show one other thing we could have done. And we'll just say, well, that goes in one time, leaving 4, bring down the 4, and goes in 5 times. 5 times 8 is 40. Okay, and you're left with 4. Now this is where you could stop. You could say 15 remainder 4. All right, some of you learned how to do division that way. And if you did that, then you have everything you need right here to get your answer. So you've got your whole number, part of your proper fraction, and then you've got your numerator right here, and your denominator right here. So we'll write that out. We've got the whole number, 15, and 4 over 8. Well, 4/8 can be reduced to 1/2. 4 divided by 2, or rather 4 divided by 4 is 1. 8 divided by 4 is 2. So now you've got 15 and 4/8 equals 15 and 1/2. 2 ways to get the same answer using long division. Okay, the next problem. Let's get some more paper here. The next problem, deceptively simple, asks us to, subtract 32 from 789. So you've got 789 minus 32. Now, if you haven't done old-fashioned subtraction in a while without a calculator, it may be a burst of cold water in your face that you got to remember how to do it. So this number has to be smaller than this number, or else you have to borrow. All right. But so 2 smaller than 9, I could just say 9 minus 2 is 7. 8 minus 3 is 5. And 7 minus 0 is 7. So the answer is 757. All right. Now the next question is, we can just make a little. By the way, just before we move on, if you wanted to check your answer, you could always try adding 32 to 757, and you should get back to 789. So 7 plus 2 is 9, 5 plus 3 is 8, 7 plus nothing is 7. Get back to 789. It's a good check, especially since you don't have a calculator. All right, moving on. The next question, you are given to ask the product of 56 and 96. So 56 times 96. So doing this multiplication right here, 6 times 6 is 36. We just write the 6 and we put a little 3 up here. 5 times 6 is 30, plus 3 is 33. Now on to this one. We're going to move over one space. 6 times 9 is 54. We write the 4 and we carry a little 5. 5 times 9 is 45. We add 5 and we have 50. You write 50. And then you put a line, and then you start adding. 6. 3 plus 4 is 7. 3 plus 0 is 3. And then just 5. 5, 3, 7, 6. The question actually asked which number among the answer choices this product was closest to. And the two that it's closest to, we need to look at. It gives us 5,400 and 5,300. The question is 5,376 closer to 5,400 or closer to 5,300? Well, here you're only 24 points away from 400, but you're 76 points away from 300, so the answer would be closer to 5,400. Next. Okay, the next question asks us to take the quotient of 456 and 23. Let me just create a little bit more room here. So 456 divided by 23. Okay. So here's something to wonder about. How many times will 23 go into 4? No times. How many times will 23 go into 45? Well, I know it'll go in once, but will it go in twice? 23 times 2 is 46, so it will only go in one time. 1 times 23 is 23. And now I have to do this little subtraction. 5 minus 3 is 2. 4 minus 2 is 2. And I bring down the 6. Okay, so now we're asked, how many times will 23 go into 226? Oh boy. There are a couple of tricks. So one trick is to multiply 23 by 10 and you get 230. 230 is really close to 226, but you overshot it. So you know in your head it's got to be 23 times 9. So it's got to be 9 times. But what is 9 times 23? Well, if you have no idea, you can just multiply 23 times 9 as a little side work and get the product. So 3 times 9 is 27. Write the 7, carry the 2. 2 times 9 is 18, 19, 20. And you have 207. So we'll put the 9 right here. And we have 9 times 23 gives us 207. This is what we will be subtracting now. Now remember our rule about subtraction. I cannot subtract 7 from 6, so I have to put an X there and put an X there and borrow. That becomes a 1 and this becomes a 16. I'm borrowing a 10. So now, what is 16 minus 7? Now that's 9. 1 minus 0 is 1. And 2 minus 2 is 0. So just 19 as a remainder. And now we go into extra innings. Put that decimal point and extend the division bar. Okay, now we're going to bring down another 0. How many times does 23 go into 190? Well, if 9 times 23 was 207, what is 8 times 23? Would that be really close but not exceeding 190? I don't know. I I could multiply 23 times 8 and just see. So 3 times 8 is 24. Write the 4, carry the 2. 2 times 8 is 16, 17, 18. That's 184. All right, so that's as close as I'm going to get to 190 without going over it, so I better write an 8 here. 8 times 23 is 184. Draw a line and subtract. Okay, so now I've got to borrow. This 0 is too small. I've got to borrow from that one right there. That becomes an 8, and this becomes a 10. 10 minus 4 is 6. 8 minus 8 is 0. 1 minus 1 is 0, so there's just 6 left over. And now we will bring down another 0. So how many times will 23 go into 60? Well, 23 times 3, 23 times 3, let's check that, is going to be more than 60. So 23 times 2 would be 46. So 2 times 23 is 46. And we will do the subtraction. This becomes a 5, this becomes a 10. So now it is 4 and 1. Okay, and now I bring down another 0. How many times does 23 go into 140? Well, I have no idea, right? So I'll say if I subtract 20 from that, that'd be about, maybe if I subtract 40, so I'm thinking in my head, maybe 23 times 6. 23 times 6, I'm really guessing here. So 3 times 6 is 18, 12, 13, 138. I hit it pretty close. So I've got 6, and you got 6 times 23, it's 138. And you are left with, got to borrow there, and you're left with 10. 10 minus 8 is 2. And now you bring down a 0, and it appears that this is just going to go on and on. Let me make sure that our math was correct, because I think, yes, it is going to go on and on. So what the problem wanted us to do is take this out to 2 decimal places and round. So it wants me to look at this number right here and check the number next to it. If that is 5 or greater, round that. So the answer that you would pick from your answer choices is 19.83. Okay? And just to show you how close all the answer choices were, here were the other answer choices. 19.93, 20.63, and 20.03. So it really did pay to take the time with that problem and get the right answer. Okay, what's the next question? We are asked, let me just get a fresh sheet of paper here. We are asked to add 6/12 to 6/24 to 1/4. Okay, so what we're looking for here is we are looking for the lowest common denominator. What is it? The lowest common denominator between 4, 24, and 12 is 24. But you don't have to, so you could do that, and you could turn all this into 24, but notice this. Notice this. Notice that 6/24 is not fully reduced. I can divide both the top and the bottom by 2, and I can reduce that fraction. 6 divided by 2 is 3. 24 divided by 2 is 12. All right, can it be reduced any further? Sure, I can divide the top by 3 and the bottom by 3. So both the top and the bottom can be reduced again by dividing both by 3, and I've got 1/4. Okay, so can 6/12 be reduced? Sure it can. Okay, I can divide both the top and the bottom by 3. Okay, I'm doing it kind of backwards, and I end up with 2/4. Right? I'm going to stop there because you can say, well, you could go down to 1/2, but I want the common denominator. So 6/24 is 1/4. Because, 24 divided by 6 is 4, so it's 1/4. You got 1/4 plus 1/4 plus 2/4. This is 2/4 plus 1/4 plus 1/4. Now you can just add the numerators. This equals 4/4, which equals 1. I love these answers when they come out nice numbers. 1. Okay, next question. The next question is, which value is closest to 85% of 25? So here's how that's written. 85% of 25. Well, first thing we need to do is convert 85% to a decimal. So there's a little decimal there that's never written. We're going to move that guy over 2 spaces and put him right there. So now I've got 0.85, and let's remember our math to English translator. Of means times 25. So 0.85 times 25. That's the product we need to do. So we can do 25 times 0.85. The only time the decimal will become important is at the end. Otherwise, we're going to multiply this exactly as if it was just your plain old multiplication. 5 times 5 is 25. Write the 5, carry the 2. 2 times 5 is 10. Plus 2 is 12. Write 1, 2, 5. And now 5 times 8 is 40. Write the 0, carry the 4. 2 times 8 is 16. Plus 4 is 20. Stack add. Like that. Bring down the 5. 2 plus 0 is 2. 1 plus 0 is 1. And 2. I got 2125, but I've got this little decimal. So I got come over 2 places from the right and put a decimal. 21.25. Okay, so I have 21.25 25. It says here which value is closest to 85% of 25. The possible answer choices were 16, 20, 22, and 18. All right, so these can be eliminated. Is 21.25 closer to 20 or 22? And the answer is 22, because you're 0.75 away from 22 here, but you're 1.25 away from 20. So we'll go with 22 and hit next. Okay, the next question is going to challenge us, but we will attempt. All right, so I've got, the question is, what is 0.98 divided by 0.54? 0.98 divided by 0.54. Okay, that is the question that we are asked to find the answer to. Now, let me just, before we start to plunge into this, which it looks like it could be some kind of a nightmare, let's just think about it for a minute. Look what's being asked of you. What is this sort of close to? What is 0.98 really, really close to? 0.98 is really, really close to, make this weird looking arrow, it's really, really close to 1. Okay? And 0.54 is really, really close to 1/2. So just as a matter of getting a ballpark idea, what if we took 1 divided by 1/2? All right? Remember, if you're going to divide by a fraction, you multiply by its reciprocal. So 1 divided by 1/2 is the same thing as 1 times 2 over 1, or 2. So 1 divided by 1/2 is 2. So what we're looking for is a number that is close to 2. So here are your answer choices. 181, 0.181, 18.1, and 1.81. Now, I don't know about you, but if this is my party, I am going to circle this one and call it a day, because it's really, really close to 2. And I'm going to be perfectly convinced that that is fine compared with these other answers, because none of those are even anywhere close to 2. We'll pick that one and move on. So that one wasn't so much math as like math reasoning, or what I like to call like shopping cart math. Okay, next question. Here, this is a 1.45 times 0.99. That's what we're asked to find. And so, again, before you start calculating, ask yourself, what is 0.99 really, really close to? It's really, really close to 1. So 1.45 times 1 is really, really close to 1.45. Just before we do all this math, let me show you your answer choices, see if you can get it. Answer choice 1 is 2.44. Answer choice 2, 1.44. Answer choice 3, 3.44. Answer choice 4 is 4.44. Okay, so which one of these is closest to 1.45? You don't have to do any more work. Let's move on. The next problem is addition involving decimals. 2.45 plus 0.54 plus 0.07. Okay, so we're just going to stack add all of those. 5 plus 4 is 9. 9 plus 7 is 16. Write a 6, carry the 1. 4 plus 5 is 9, plus 1 is 10. Write a 0, carry the 1. Put the decimal. 2 plus 1 is 3. 3.06 is the answer. And that's it for that one. All right, the next question asks us to pick which one of the answer choices represents the smallest value. 0.000799, 1.0009, 0.11189, and 1.00095. All right, which one's the smallest number? And it is this one. It has the most leading zeros after the decimal. All right, and next question we can fit here. It says 5.36 minus 0.78. Right, that's all they want. Okay, so when we're doing this subtraction, we can't subtract 8 from 6, so we move over 1. We can't borrow there because that one's going to need its own borrowing. So we go over to the 5. We put a 4 there. Now we subtract 1 from, it would be 13. So now it's going to be 12. And then this becomes 16. So 16 minus 8 is 8. 12 minus 7 is 4.58. To check that, make sure you add 0.78 to double check that your result is 5.36. You have 6, carry the 1. So that's 8. 8 plus 8 is 16, carry the 1. You have 5 plus 7 is 12, plus 1 is 13. Carry the 1, put the decimal place, and now you have 4 plus 1 is 5. So 5.36 minus 0.78 is 4.58. I want to show this one more time because this really is a skill that we all seem to forget. What happens when you have to borrow over multiple places? So the problem was 8 was bigger than 6. So I move over one place and I want to borrow from the 3. But I can't because 7 is bigger than the 3. So it's no good. So I had to go over to the 5. So here's how this works. We're going to cross out the 6 and cross out the 3 and cross out the 5. We'll subtract 1 from the last thing that we're going to borrow from, and that becomes a 4. Now, we're going to add 10 to the 3. Now you got 13. But subtract 1, because we're going to be borrowing from that over here. So I've got 13 minus 1 is 12. Okay, and now I move over to the 6, and I write 6 plus 10. I've got 16. Okay, run through that over and over again until you get it, because it is kind of torturous. But this is the answer, 4.58. Okay, moving on. We only have 2 more to go. Here's a question. Janet, we'll write it out. Janet makes dolls. Currently, she produces 23 dolls per month. If she increased her production by 18%, so increased her production by 18%, how many dolls would Janet produce each month? How many dolls? Okay, so we need to increase the current production rate, which is $23 per month, by 18%. And how do we do that? Well, we take the existing rate of production, $23 per month, and we multiply it by 1 plus the growth rate. Okay? 1 plus the rate that we're going to increase by. All right, so we'll say current rate is 23 per month times 1 plus the growth rate, which is 18% as a decimal. 1 plus 0.18, that's 18% as a decimal, 0.18. So that's 23 times 1.18. And I need to actually do that. 1.18 times 23. That's the multiplication I need to do. So 8 times 3 is 24. Write a 4, carry the 2. 3 times 1 is 3, plus 2 is 5. 1 times 3 is 3. 8 times 2 is 16. Write the 6, carry the 1. 1 times 2 is 2, plus 1 is 3. And then 1 times 2 is 2. Stack add. Oops. Sorry. Cut you off there. Stack add 4. 5 plus 6 is 11. Write the 1, carry the 1. 3 plus 3 is 6, plus 1 is 7. And 2. Now we're going to pull that over 2 decimal places. And so I've got 27.14. All right? Now the question asked, how many dolls would she be producing per month? And we have to ask ourselves, can you produce a fraction of a doll? No. So she can produce 27 dolls. And that was indeed one of the answer choices. So we'll select that and move on. The big thing is, if you're going to increase the production by some percentage, just multiply the original times 1 plus that as a decimal. Okay, number 14. Use a fresh sheet of paper. Number 14. 2 cars are side by side. One is 3.9 meters long. The other is 6% shorter. How long is the second car? Okay. So we got car number 1 is 3.9 meters in length. And it says here the other is 6% shorter. Okay. So what does that mean? Here's how we work this. We're going to use our existing formula. So I want to know what the other car length is. So here's how this works. Instead of increasing by some percent, we're going to decrease by some percent. So here's how this works. The formula is 3.9, which is the original, multiplied by, open parentheses, 1 plus r. All right, so in this case, they're giving us what 1 plus r equals. 1 plus r equals 6%. Okay. Wait a minute. Because it's, I apologize. Because it's decreasing in size, it is 1 minus r. So it depends on whether it's increasing or decreasing. So now 1 minus 6%. All right, so what is 1 minus 6%? Well, we have 100% minus 6%, and that equals 94%. So what I need to do is multiply 3.9 by 94% as a decimal. So 3.9 times 0.94 will give me the length of the shorter car. So 9 times 4 is 36. 3 times 4 is 12, plus 3 is 15. 9 times 9 is 81. Carry the 8. 3 times 9 is 27, plus 8 is 35. And now stack add. Got 6. 5 plus 1 is 6. 5 plus 1 is 6. And 3. And we're going to move over 1 decimal place, 2 decimal places, 3 decimal places. So I've got 3.66666. It wants us to round to the nearest tenths place. Okay, so I'm going to round to 3.7 meters. And that is the answer. Final question, number 15. A rectangle's width, all right, let's draw a rectangle. I'm not even going to read the rest of the problem, just draw a rectangle. And it says here, a rectangle's width is 23 centimeters, and its length is 9 centimeters. I guess I labeled them wrong, right? Doesn't matter. It wants to know the area. Okay, so the area equals length times width, which means 23 times 9. Okay, so we'll do that right here. 23 times 9. Okay, 3 times 9 is 27. Write to 7, carry the 2. 2 times 9 is 18, plus 2 is 20. 207 centimeters squared. Okay, 207 square centimeters. That's the answer. And Very good. Let's just go through our answers. It's saying that we got 13 out of 15 correct. Wonder which one we did wrong. Oh, it's saying that 56 times 96. Let me go back to that one. What happened there? Where did I do? Okay, so here I did, it's saying I did the 56 times 96 wrong. I said the value was closest to 5,400. That's what I chose. Okay? Oh, okay, so that wasn't wrong. And then, yeah, the value is closest to 5,400, so that was correct. I don't know why that was marked wrong. And then on this problem, the next problem, it says it was incorrect. It says 456 divided by 23 equals 19.826. Rounding up, we get 19.83. That is what I chose. So that was correct. I don't know, that scoring guide is just wrong. So we got them all right. Good. That's what we wanted. All right, so those are all correct. I hope that was helpful, and this should give you some confidence in walking into the TSI test without a calculator. Again, these questions came from the free Mometrics, and I'll give them a little ad here at the end. Mometrics, I've used this company for my own teacher prep, and it's good. Mometrics. Mometrics TSI prep. And this, of course, is for the math TSI. All right, so please frequent this company and give them your business. They are a very good test prep company. All right, have a nice day.